Okay, so number 33 from the regions that we're doing here. Okay, I get it. You may remember these from last year. You might be frustrated with these because these can be frustrated, especially you do all this work and then you find one of the variables equals this long decimal and you know that's not right. Okay, but I am telling you, if this shows up in 4 weeks, we're pretty lucky. All right, these are the easier type versus all the others that are on there. All right, so X, Y, and Z. Here we go. Your first job is to pick 2 of them right now. Pick 2 of them and decide what variable you want to eliminate. So somebody in here is going to start us off. Okay. If you want to do it your own way, fine. See if we end up at the same spot. But I'm going to ask somebody right now to pick 2 equations and then tell me what variable you want to eliminate out of those 2 equations. Here we go. 9. First, second, third. Which ones are we taking?
First.
Okay, and the
Z.
Okay, but you got to pick another equation though.
Oh, okay.
First and the
third.
And you want to eliminate Z.
Yep.
Okay, so we'll take the first one. Now, before I take the third one, you want to eliminate Z. What am I going to have to multiply this whole thing by to eliminate Z? Well, there's a negative 4Z here, so I need a positive 4Z here. What am I going to multiply by? 4. All right, I'm going to have to multiply that third one by 4. Everything by 4, including what's on the other side of the equal sign. So I need somebody to do that for me. Here we go. 8. Want to distribute the 4 for me? Yep.
Plus 4y.
Yep.
Plus 4z.
Yep. Equals.
64.
Okay, there we go. Tell me what's left now, because I know the z's will cancel out. That's what we wanted. What's left with the x and the y's and the numbers? Here we go. 4. I just want you to combine everything. I have 2x minus 16x. Plus equals. Okay, everybody good? Okay, next job. Pick 2 more equations and eliminate z again. Once you decide what variable to eliminate, you got to eliminate it again in another set. All right, so obviously don't pick the first and the third. You got to pick the second and another one. We're good. Good. Thank you. Okay, you need to pick the second and another one to eliminate z. So I need somebody. Here we go. Number 2. You want to take the second one and the third one again? You want to eliminate z? Okay. So let me get rid of this here. So let me rewrite the second one. X minus 2y plus 5z. All right, if you want to take the third one, what are you going to have to multiply it by? -5. All right, let's multiply it by -5, everybody. Many combinations of ways. This is not the only way to do it. Many combinations of ways here. 4. Want to distribute for me? Yep. Negative. Yep. Don't want to participate with us today?
No, I live my back.
Oh, are we going down this hole again that we started to come out of the second quarter, but are now going back down? And you still owe a calculator.
Yeah.
People are pretty lucky in here. They have their own right now. 11. Where are we going from here?
Okay, so you got 21x.
Yep.
Minus 7y.
Equals?
-5.
5?
Oh, that's just. Oh, I'm sorry. -77.
Congratulations, you picked a nice route. Okay, so once you've eliminated, everyone see how I have two equations left now? Now you got to solve for another variable using those two only. And nice job, because what's going to happen? Y's are going to cancel out. All right, I'll still rewrite it though. Negative 14x plus that 7y equals 63, and then I have 21x minus 7y equals negative 77. Yeah, that's nice job, everybody. Nice job. The y's are going to cancel, and what's going to be left here? Go ahead, 13. What's going to be left? 7x. Hopefully a number divisible by 7, right? Cross your fingers. Ah, there it is. That's there. You're darn right. Makes my all our work we just did worth it. So x equals -2. All right. There's 1 out of 3. How do I get the other variables now? I got one of them. How do I get another one? Okay, take x, go back to one of these two originals right here and plug it in. Anybody have a preference? The -14 or the 21?
-14.
Okay, I'm fine with that. Here you go. So we're going to say -14 times -2 plus 7y equals 63. You guys are going to go solve for y for me. Take your time. I'm in no hurry here. 13 again. When you get y, let me know. 5. And then final step, how do I get, I have x, I have y, how do I get z? Go back up top. Anybody have a preference, the first, the second, or the third?
Second.
Do whatever you want. I'll do the first, sure. Do whatever you want, though. All right, I got to go back up there. 2, 3y. So 2 times -2 plus 3 times 5. What's the deal with the z? Minus 4z. All right. Again, take your time. 7, take your time.
I'm ready.
And do you guys know how long you must stay in 4 weeks? 2 hours. Why do I tell you that? Because now you can take x, y, and z and use our good old store button to see if they equal -1, 3, and 16. Okay? Now, I will warn you, you're not going to get whole numbers every time. Last year, this type of problem was on in the January exam, and one of the answers is like 1.5. All right, but if you get 1.6829, 4, and 8, that's probably wrong. Okay? But check it. You guys all good? Again, we may just want to stand up and applaud if we see this on the test in 4 weeks. All right, that's worth 4 points right there. We just did 4 extra points on top of whatever you already have. Okay? And it doesn't get any easier. You may not think it's easy, but none of the other problems are going to be this easy. Anything you want to ask? Okay, we're good. We're going to show a little video in a couple minutes here. Nope. Okay. We're good there. All right, here we go. So go to your notes, stat notes. Still need a calculator with you. We have one major section to do in this unit, and we are done with Algebra 2. Not just stats, but Algebra 2. Test Tuesday, we get back. Tuesday. Here's the big chunk we got to do. We're going to do experiments now, the second half of this unit. Experiments. And so, for instance, this first experiment I got with the Swimming with Dolphins Day here, I got 50 people, and I think I've created a new pill that's going to increase weight loss. So what I do is I take the 50 people, I divide them up into one group of 25. Here's my weight loss pill. Go for it. I get another group of 45. That's my control group. I give them a pill, but they think it's the weight loss pill, but it's not. Okay, it's actually got nothing in it. The people who took the weight loss pill, they lose weight. The people in the control group, they lose weight too. Believe it or not, they lose weight. They lost a little bit more weight than the control group. Here's what we need to figure out by the end of this unit is, was it because of the pill? Okay, was it actually because of the pill, that group that took the pill lost a little bit more weight than the control group? Okay, there could be two different reasons why that group lost a little bit more weight. One's called induced variability, which means, hey, the pill actually works. The pill actually caused the weight loss. That's what's called induced variability or induced causes. What else could have been caused by though? Other than the pill? Why did that one group? Yeah, great, I gave them the pill, but that may not be the reason. What's some other reasons why maybe that group lost a little bit more weight than the control group? Like what? Eat healthier, right? Maybe they ate healthier, so they lost a little bit more weight. It had nothing to do with the pill. That's called natural causes. Anybody else? I got a couple others I want to write up. What's up? Worked out more. Anybody else? The only one I'm going to put up there is maybe that group had a better metabolism, right? Those are all called natural causes. So that's what we got to determine. But mathematically, though, was it because of the pill or just by random chance that this group here lost more weight? All right, so does everyone see what we're going to try to determine here in these ones? And today I'm going to show you one which is, does swimming with dolphins reduce depression? Okay, that's what's going to be today. Is actually swimming with dolphins, does that conclude that it actually leads to a reduction in depression? Okay, so I'm just going to play you first. What I need you guys to do is go to this chart here, which I'll refer back to in a second, which gives us our results. But just some background. I'll just give you guys some background here about what's happening. All right, I'm sorry, the guy is a little. You'll see.
Therapeutic for patients suffering from clinical depression? To answer this question, researchers wanted to focus on whether or not swimming in the presence of dolphins helped some depression patients improve at a higher rate than other individuals that were in similar circumstances but did not swim with dolphins. The researchers recruited 30 subjects aged 18 to 65 with a clinical diagnosis of mild to moderate depression. The subjects were required to discontinue any antidepressant drugs or psychotherapy 4 weeks prior to the experiment and throughout the experiment. These 30 subjects went to an island off the coast of Honduras, where they were randomly assigned to one of 2 treatment groups. Both groups engaged in 1 hour swimming and snorkeling each day, but one group did so in the presence of bottlenose dolphins, and the other group did not. It's important to note that the participants in the dolphin group and the control group experienced identical conditions except for the presence of dolphins. At the end of 2 weeks, each subject's level of depression was evaluated, just as it was at the beginning of the study. Our response variable is defined as whether or not subjects achieved.
Okay, so everyone get the gist of the experiment here. All right, so they did that, and those are the results right there, the two-way table you guys see. All right, so you guys can see how many reduced their depression that were in the dolphin group, how many reduced their depression that were in the control group, and so on. All right, everyone good? Of the 15 people in one, 15 in the other. All right, so this first one I want right here, and I know you don't know what this means yet, but I'm going to ask you to find it when I tell you, is how many people reduce their depression in the dolphin group? What percent of people in the dolphin group reduce their depression? That's what I want from you right now. What percent of people in the we put in the dolphin group that got the dolphins reduce their depression? That's what I want right now. What percent of people? Okay, a little help finding that. 3, a little help finding that. How many people? 10 out of 30. No, not 30, just in the dolphin group. So 10 out of 13 is how many reduce their depression overall. It's all right. 15, you're a little rattled. It's all right. It happens. They're great ones. So 10 out of 15 reduced depression. So out of the 15 people I had that swam with dolphins, 10 reduced their depression, which is you're not off the hook yet, Elena. About what percent? It's about 66.7%. So this was about what, 0.667? Because I want to leave it as a decimal like our dot plots yesterday. And again, what does this value mean? Just jot it down. This is the proportion of dolphin group that reduced depression. You don't have to worry about the symbols at all. Okay, everybody good so far? All right, I want to go a little bit slower here. It might be painstaking, but sorry. Okay, next. What about the people in the control group? Give me a proportion of the people in the control group that reduce their depression. That's what I'm asking for in B. What's the proportion of people in the control group? That's our reduction in there. 7, little help here. 3 out of 15, which is what as a decimal here? Which is equal to 0.2. Yep. And again, what does this mean? This is the proportion of control group that reduced depression. Big difference, huh? Big difference over the ones who saw the dolphins. All right, now I want you to subtract the 2 for me. The dolphins minus the control group for me. 0.667 minus 0.2. Because that's the value that's going to be key. And we end up with 0.467, yeah. And you don't need to write down what it means, but here's, if you put that as a percent, what's that as a percent? About, let's just say about 47%. Here's what that means. About 47% more people in the dolphin group reduce their depression than the control group. 47%. 47%. Is that enough to say that the dolphins worked? Don't know yet. Because it could still be by random chance. Okay, that they just happen to be in a group where the more people in the dolphin group reduce their depression by random chance. Quickly here, what if this number ended up being negative? Anybody know what that means? That number ended up being negative, meaning, ready? That number right there was bigger than the one on the left. What would that mean then? The control group had more members reducing depression. Control group had more people with a reduction in depression. If that was negative. Okay. Okay, let's actually find out. Was it because of the Dolphins? That 47% more in the dolphin group. Was it actually because of the Dolphins? All right, here we go. Let's keep watching here and what's going to end up happening. So I'm going to get you guys to the point where they have that chart. He starts talking about the chart a little bit.
A summary of the results are shown in the two-way table.
Same table we
We
have.
see that subjects in the dolphin therapy group were more likely to show substantial. In this group, 10 of 15, or about 67%, showed substantial improvement compared to only 3 of 15, or 20% in the control group. Our observed statistic is the difference in the proportion of improvers, or 0.467.
This is what we just
This
found.
appears to be quite a substantial difference. Now, there are two possible explanations for this observed difference. It may reflect a genuine tendency for depressed individuals to be more likely to improve if their activities include dolphins.
So they're saying the
In other
Dolphins
words,
was because of
the
it.
dolphins really helped. Perhaps, however,
Or
the 13 subjects were going to show substantial improvement and the 17 were not, just by being participants in this experiment, regardless of which treatment group they were assigned to. And we just happened, by random chance alone, to assign more improvers to the dolphin therapy group. Now let's think about how we're going to set up this simulation.
okay, so is everyone seeing what he's saying there? What the two reasons possibly could be? Yes, it could be by the Dolphins, or just hey, randomly we just put these guys together, and the people in the Dolphin group just happen to lose more. Had nothing to do with what animal we put them in. Okay, so now we're actually going to test it. Which one would it be?
Regardless of which treatment group they were assigned to, and we just happened, by random chance alone, to assign more improvers to the dolphin therapy group. Now let's think about how we're going to set up our simulation. If the null hypothesis is true,
Don't worry
then
about the whole
dolphin
null
therapy
hypothesis.
is no more effective than the control therapy. And we were going to have 13 improvers and 17 non-improvers, regardless of which group they were assigned. Hence, the assignment of the subjects to the groups doesn't matter, and we can just randomly assign the subjects' results to the two groups to see what would happen under a true null hypothesis. We can perform this simulation with index cards. We will let 13 cards represent our improvers, and 17 cards represent our non-improvers. We will then simulate the random assignment process of the subjects to the two groups by shuffling the cards. Then we'll put 15 cards in one pile to represent the dolphin therapy group, and 15 cards in another pile to represent the control group. This way, an improver is equally likely to be assigned to the dolphin therapy as to the control group. We will then compute the proportion of improvers in the dolphin therapy group and compute the proportion of improvers in the control group. Finally, the difference in these two proportions is what could have happened under the assumption of no association between swimming with dolphins and substantial improvement in depression. Let's try this out. Here are cards representing the results from the actual study with
Everyone see this matches your table. Everyone see I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 improved in the dolphin, and I got 3 that improved in the control. So this is what actually happened. Right? So we're going to shuffle them up.
Improvers in the dolphin therapy group and 3 improvers in the control group. We shuffle the cards and deal them into 2 piles of 15.
So now we're just randomly put them into two groups of 15. All right, so randomly put them in, recalculate what you guys just did for me in your table.
By chance, we got 6 improvers out of 15.
So that's where that 40 and the 46 comes from.
And 7 improvers out of 15, or 46.7% of the control group. This gives us a difference in proportions of a negative 0.067. Let's start making a dot plot of our simulated differences.
That's what you guys did yesterday for me.
0.067 being our first dot. Now let's repeat this process. This time we got 8 improvers, or 53.3% in the dolphin therapy group, and 5 improvers, or 33.3% in the control group. This gives us a difference in proportions of 0.2, and we will add this dot to our dot plot of could have been values.
Okay, so the dots he's putting on is what would happen just by random chance. What was our observed value before? When we actually separated them, what was our observed value before? What did we come up with? Point what? 467.
We repeat this process again.
Okay, all right. Where's 0.467 on the dot plot so far? Right out here, right? And all these dots are represented by what? Random chance. So I know we've only done 2 right now, But do you think that number occurred by random chance, what we got?
Most likely not.
Probably not so far. But does 2 make you great?
No.
We've talked about in this unit, you got to do a ton of simulations to get an actual result, correct? All right, so right now we're starting to think, I don't think that result was by random chance. I think it was actually because of the Dolphins. All right, so watch him. He'll do a ton more.
This time we find that 7 improvers, or 46.7%, end up in the Dolphin therapy group, and 6 improvers, or 40%, end up in the control group. This gives us a difference in proportions of 0.067, and we will add this dot to our dot plot. Note that none of these simulated results are as extreme as our actual observed difference of a 0.467. Hence, it is starting to look like this observed difference might be unlikely to occur just by chance. But we need more than just 3 simulated results.
Darn right we do.
In class, I would have each of my students shuffle the cards and compute a difference in proportions. They would then plot those differences on the board, and the results might look something like this. In this class of 30,
Let me ask you now. 0.467 out there. Still look like it's by random chance? No, right? Everyone's seeing that. Okay, but a class of 30 is probably not going to cut it. So what happens instead, and this is where I'm going to end this, is you got to do a heck of a lot more. So look on your paper right now. I believe might be on the next page. We decided to do it 100 times, 100 shuffles of them. And everyone see what we got out here. Okay, so those are our results up there after 100 shuffles. Where's our 0.467, guys? Yep, still at the end here. And all these happen just by random chance of a simulation. So what do you think our conclusion is going to be here? Did their reduction in depression happen by random chance or because of the treatment of the Dolphins? Probably the treatment of the Dolphins. Everyone see how we landed at that point? Okay, we just do a whole bunch of random simulations, see where our value lands, and say, well, it didn't happen by random chance because it's way on the outside. Okay? Now, the problem we're going to run into is, well, what if our value was, I don't know, like say right there? And it's kind of hard to judge. Everyone agree that's hard to judge. We could make an argument for it's unusual, or we could make an argument for it happened by random chance. So what can we do mathematically to actually say, okay, it's by random chance or it's not? Here's where yesterday's class comes into play. Remember finding the confidence interval. Find the confidence interval first. Okay, so out of the simulation we did, look back in your packet if you need to. How do I get that confidence interval? What is the formula? Here we go. 13. Here we go. What's the formula for my confidence interval? Yep, no problem. Look back in your packet. Mean plus or minus margin of error. Yep. Okay, need somebody else. How did I find margin of error yesterday? Oh, 7, margin of error. Yep.
Plus or minus 2 times standard deviation.
Okay. So here we go. Find that confidence interval. And then I'll show you how you can tell if it's unusual or not. Okay, number 9, using the simulation we just did. What's the standard deviation?
0.186.
Okay, so go ahead, find the margin of error, plus or minus. $10, what's my margin of error here? Plus or minus? 372. So now let's go back. Here's my confidence interval. Mean, 0.008. Add and subtract the margin of error, 0.372. 11, when you get to it, let me know your confidence interval. 0.38 on one end. What about on the other end?
Negative 0.364.
Okay, so if we were ever unsure, because this is an obvious one, all right, that it didn't happen by random chance. All right, but let's say it's not obvious. Look at my interval right now. Where's 0.467? Outside it. All right, and this represents how many percent of the scores here? 95%. So if your value is outside the confidence interval, it's not by random chance. Okay, it's not by random chance at all. Okay, it is an unusual value, so that would tell me the treatment worked. All right, so let's finish this up. I'm just going to go right to part C. Could one conclude that swimming with dolphins causes a decrease in depression on this experiment? Yes, no? Yes? Because what was our value? 0.467 falls outside, or what? Falls outside the confidence interval. Yep. Meaning it did not happen by random chance. Good there? Okay, I'm going to do one more with you before we call it a day. I'm going to go deep. Can you guys go to page 29 for me? Page 29 in your packet. I'm going to test a little herbal medicine here for me.
I'm on the code of conduct, so
Sure. The effectiveness of an herbal compound to treat the old cold. So people in Group A, they were given the actual herbal compound, and Part B was not. Did it actually work? So first thing you guys need to find, what's the severity of the cold in Group A? What's the severity of the cold in Group B? So I need you to find the mean for me right now. Okay, find the mean of each group. Shouldn't take too long. Okay, what do you got for me? You guys could just tell me here, what's the mean for Group A? 1.8. A little parallelogram action. 1.8. How about the mean in Group B? 2 point. I have 2.4. Okay, is there evidence that the herbal compound works? Here's what we got to do. We got to first subtract them. Okay, we got to subtract them. So we're going to need the difference in the means. That's the first thing you always find is the difference in the means. So it'll be 1.8 minus 2.4. Difference in the means, 1.8 minus 2.4. Difference? Negative 0.6. Okay, we take that value. We go to the simulation now. See where 0.6 is in the simulation, please. If I could get there myself, I'll get there. One job. Right before break there. Yep, there we go. Okay, where's 0.6? Everyone see where it is? Right here?
Yep.
All right, hey, I don't know. Is it an extreme value?
Nope.
Or do you think it's caused by random chance?
Probably college.
You think it's caused by random chance?
But we gotta see.
Okay, let's find out now. Okay, let's see if it's on that outer 5%. All right, so we have the mean and the standard deviation. What are we going to look for? Confidence interval, right? And I can't do that unless I have my margin of error. Here we go. Margin of error is going to be plus or minus 2 times, which is 0.57. Plus or minus, what do you get there? 1.14. And now to find the confidence interval, you're going to take, what was my mean? 0.3 plus or minus 1.14. And what do we end up with?
Negative 0.84.
1 point. You tell me. Where's our observed difference? Outside, right? So what do we say? Did it happen by random chance? No. So what do we say about the herbal compound? It works. Yep. That's why, hey, that's why we don't go by looks here. This is why we have a mathematical way of figuring out if it actually fell outside or not. Okay? Oh yeah, never mind. I don't know what I was thinking. Yeah. So I was thinking on my own here. So let me regroup here. Where's 0.6? Inside. So that would happen by random chance. So the herbal compound did not work. Thanks, everyone.
Wait, what?
Where's 0.6?
Easy.
Hey. Where's 0.6?
Oh,
Inside.
Yeah.
Right? So if it's inside, that happened by random chance then,
That's
not
what
because
I'm
the
saying.
compound did it.
And then someone's like, the herbs work. That was me.
The compound did not work.
It's all right, man.
The difference was because of random chance. Thanks, everybody. Always count on period 8. All right. Hey, enjoy and relax on that break because it's going to get pretty intense when you get back. As far as finishing this unit and getting ready for that Regents.
It's all secrets.
Oh, we got a calculator back, everyone. And in all seriousness, hey, last thing here, in all seriousness about these calculators, I only have so many. And there's people in here and people in 5th period that borrow them. I don't have any extra to give for the Regents exam. Okay, I got no more extra after the Regents exam. So think about that. You guys might want to find where yours is, figure out the situation. Or borrow it from somebody for a week.